like I told you, there are two options to make this current to be constant. Because you have the voltage over the resistor, you can do this wrapper to be a constant like that. We know our voltage will drop in time, so you need also to drop the resistor. This is the first of the options to draw the value of the resistor over the time, and you will make this wrapper to be the current to be constant. You can do that with let me think. You will need constant resistors, the power load. So the power load will be let me think, about 1 ohm, and you need to add something to can be changed in the time. You can change the resistor. The MOSFET is a variable resistor, so you can change the internal resistor RDS on of the MOSFET. So you can take the MOSFET RDS on, and this will be, I don't know, about on a logic MOSFET will be something when it's full open 0.028 ohm, and when it's closed it's about infinite, it's 1 mega or more. So if you can control the MOSFET to only open, not full open, but only at half or less of that, you have a resistance. So you can add this resistance to the main load, and like that you can have an variable resistor here and make this wrapper constant. But to do that, you'll need to take a MOSFET with an internal resistor which can be controlled. So let's see what we need. Let's suppose you want to discharge with only 1 amps per hour, a constant. So in the first case, when the battery is fully charged, you'll need to be 4.2 volts. To be 1, we need to have a resistor or 4.2 ohms. When this battery is discharged, you'll have 2.5, and also you need volts to have a 2.5 resistor ohm. So if you take a constant resistor load, so your R will be 1 ohm, you need to add when the battery is full, you need to add an MOSFET resistor RDS to be something like 3.2 ohms. And when the cycle is completed, we need to have the resistor 2.5 here ohm on the end. So you have 1 ohm plus a resistor of 1.5 ohms. To do that, you will need your MOSFET to be controlled between 1.5 ohm, the RDS of the MOSFET, to be to 3.2 ohms. So you need to find a good MOSFET with this kind of resistor, internal resistor, and control it. To control MOSFET, you know, the MOSFET depends of the how much voltage you apply on the gate. So this is the gate, this is the source, this is the drain. So if you want to control the resistance of this MOSFET, you need to control the voltage from the gate. If you use an logic MOSFET like ERLZ 44, I use that because These MOSFET have a very little air resistance, have about 0.028 when it's full opened, so it will no be any voltage dropped when I make my first circuit. So these have this 0.028 ohms when the voltage on the gate, V gate, will be 5 volts. But if you check the MOSFET graph, you'll see your MOSFET it's still open if your V gate is 2 volts, only 2 volts. It will be already open, and here this one, the resistance will be about 0.08 ohm. So to control this resistor with between 1.5 ohm and 3.2 ohm will be very difficult. You need a very precise voltage on the gate. You will need something with some about, I don't know, some millivolts to control it. So it will be very hard with the microcontroller to have a constant load. Maybe if you will use another type of MOSFET, if you use not a logical one, you can find a good one with this value and can be controlled. You'll need something like that to control it between V gate to be your V gate. As you know, your Arduino can supply 5 volts, so you need to have on 5 volts to be the resistance of 1.5 ohm. So you'll need to find the good one. I don't know what MOSFET can do that, but you need that. So I will not take this approach, because it will be very hard for me to control it.